So for this related rates problem, we're looking at the circumference of a circle and the area of a circle. So we've got a circle drawn right here. There we go. And our two formulas we're going to use are circumference and area. So if the circumference is increasing at a constant rate of 4 feet per second, and that means the dc over dt, or the change of circumference over the change in time, is 4 feet per second, where feet is the units for circumference and seconds is the units for time. So what we're going to do is we're going to take this formula and we are going to differentiate it. So dc over dt equals, now 2 and pi are both constants, and the derivative of r is just 1, but it's with respect to time, so it's dr over dt. And since we have this, we can now plug in for dc over dt. So we have 4 feet per second equals 2 pi dr over dt. And if we divide both sides by 2 pi, or if we multiply it, if you think about it, by 1 over 2 pi, since we 1 over 2 pi, that gives us dr over dt equals, and the 4 and the 2 simplify. So you have 2 over pi feet per second, and those are the appropriate units because a radius is a linear measure, so that means the radius is changing at 2 feet per second. And we needed that because when we do our next equation, because we're trying to find dA over dt, you would notice that we would need dr over dt. So, and if you didn't notice that originally, if you were like, oh, area of the circle, and you started here, you could also start with this equation, and then you're going to be like, wait, I need dr over dt, and that's when you would go back and get this equation. I went ahead and did it, but you could do it second. So now let's take the derivative of the area formula. So you have dA over dt, which is what we're looking for, and we are going to take the derivative of pi r squared. Again, pi is a constant, and the derivative of r squared is 2r times dr over dt. So it gave us when the radius is, and we now know dr dt. But like I had said before, if you got here and you hadn't yet found dr dt, you could just then go do the circumference formula. So dA over dt equals 2 pi, and our radius was 7 feet, and our dr over dt is 2 over pi feet per second. So when you multiply that all together, you get dA over dt equals, so 2 times 2 is 4, and 4 times 7 is 28. Pi's cancel out, feet squared per second. So the area is changing at a rate of 28 feet squared per second.